Shadow document object model. Encapsulating styles and markup in modern web components. This is a fundamental concept for building reusable and encapsulated components on the web. Shadow document object model is a web standard that provides encapsulation for document object model trees, cascading style sheets, and JavaScript. It creates a scope document object model tree attached to an element. It isolates cascading style sheet styles from the main document. This prevents style conflicts with the rest of the page. And it provides a foundation for building self-contained web components. In this diagram, the gray portion represents the main document. Inside the main document, we have a host element, which is the custom element. The blue box indicates the shadow document object model. Inside that, you have the shadow content and the cascading style sheets and JavaScript. In this slide, we will explore the key differences between the shadow document object model and the regular document object model. On the left, we have the regular document object model, which has a global scope for cascading style sheets in JavaScript. Styles can affect or be affected by other elements. Document-wide selector queries can find elements. There is no built-in style encapsulation, and there is a potential for naming conflicts. Here is an example of creating a regular document object model element. On the right side, we have the shadow document object model. This has encapsulated scope for cascading style sheets and document object model. Styles are isolated from the main document. Document queries cannot see inside the shadow document object model. It has built-in style encapsulation and prevents naming conflicts. Here's an example of attaching shadow document object model. Let's discuss how to create a shadow document object model. The first step, select or create a host element to attach the shadow document object model. The second step, use the attach shadow method with mode option. The third step, add content to the shadow route using standard document object model methods. Fourth step, shadow document object model is now encapsulated within the host element. The code snippet shows basic shadow document object model creation. With mode open, the shadow route is accessible via JavaScript using element.shadowRoute. With mode closed, it's not accessible from outside. Shadow document object model has two modes, open and closed. In the open mode, the shadow route is accessible from JavaScript outside the shadow tree. It is accessible via element.shadowRoute. External scripts can access and modify the shadow document object model. It is useful for reusable components that need to be customized. It is the most common mode for web components. The code snippet indicates how to access shadow document object model later, when the mode is open. On the other hand, when the mode is closed, the shadow route is not accessible from JavaScript outside the shadow tree. Element.shadowRoute returns null. External scripts cannot access the shadow document object model. It provides stronger encapsulation and is used by built-in elements like the video tag. The code snippet represents how it returns null when the mode is closed. Here are the key principles of styling in shadow document object model. Styles defined inside shadow document object model are scoped to the shadow tree only. Styles from the main document do not affect elements in the shadow document object model. Styles in shadow document object model do not leak out to the main document. Cascading style sheet custom properties, variables, can pierce the shadow boundary. Use :part and slotted for targeted styling. The code snippet represents a shadow document object model styling example. Shadow document object model slots, composing content with shadow document object model. Slots allow you to place external content inside shadow document object model. Content from the light document object model is projected into the shadow document object model, which enables composition while maintaining encapsulation. There are two types of slots, the default slot and named slots. The default slot uses the slot tag without a name attribute. Named slots uses the slot tag name equal to target specific content. This code snippet represents how to define Shadow Document Object Model template and how to use it. Events cross shadow boundaries with retargeting. Some events are stopped at the shadow boundary. Event.target is adjusted to maintain encapsulation. Here is a diagram that represents event flow in Shadow Document Object Model. First there is a capture phase, then the target phase, and then the bubbling phase. The code snippet here shows how to create a custom element with Shadow Document Object Model and dispatch a custom event. Shadow Document Object Model use cases. Number 1. Web components. Create reusable custom elements with encapsulated styles and functionality that will not conflict with the main document. Number 2. Style isolation, which prevents external cascading style sheets from affecting your component's appearance and keep component styles from leaking out. Number 3. Third-party widgets. Embed external content or widgets in a page without worrying about style conflicts or document object model pollution. Number 4. Document object model encapsulation. Hide implementation details and protect component internals from external JavaScript manipulation. Here are some guidelines for effective implementation of Shadow Document Object Model. Use open mode for components. For reusable components, prefer mode open to allow inspection and customization. Use closed mode only when necessary. Leverage custom events. Use custom events with composed equal to true to communicate across shadow boundaries while maintaining encapsulation. Provide styling hooks. Expose cascading style sheet custom properties and parts to allow styling without breaking encapsulation. Keep shadow trees focused. Design Shadow Document Object Model with a single responsibility. Complex components should be composed of multiple Shadow Document Object Model elements. Optimize performance. Minimize document object model operations inside shadow trees. Use templates and document fragments for efficient rendering. Ensure accessibility. Use proper area attributes and ensure keyboard navigation works correctly across shadow boundaries. Here are some further resources: the MDN Web Docs, Web Component Specifications, and Google Developers. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.